Hello students. Today the topic we are going to see is the asynchronous task in Android. See, first of all, before going in detail about asynchronous task, we need to know what it is. First of all, it is a class. It's a special class in Android which is going to perform background processing and also helps us in communication and updation of the application's user interface. See, mostly there is a very important problem in Android development, mostly of user interface responsiveness. Partly it is the fault of the Android implementation, but most of the faults will be occurring at the developer side. So what we're going to see here is like when to use asynchronous task and what it is basically. It is going to be helper task as I already told. This class will be helping us to do or perform the background operations without manipulating the threads or the handlers. Now, what is a handler? A handler is allowing you to send and process messages and runnable objects associated with the thread's message queue. An asynchronous task is intended to enable proper and easy use of the user interface thread. So these are things we need to remember about the asynchronous task. The next is life cycle. Okay, before going to the life cycle, let me just tell you asynchronous task only helps in background operations. It is not recommended for huge download of data or CPU intensive task. We want to run some threads for long amount of time, then I can use these classes or Java threads like Java util concurrent executor or Java util concurrent thread pool executor combined with the Android OS handler if I want to keep the threads running for a long period of time in the background. The next is about the asynchronous task lifecycle. As we can see in the diagram, there are four major methods. Asynchronous task has four methods. What are they? On pre-execute method, do in background method, on post-execute method, and finally on progress update method. So what are these methods useful for? The very first method is on pre-execute method. As you can see in the diagram, that's going to be the first, it's going to help in set up the task. That is, for example, I want to instantiate the variables, give values to the variables, or declare the variables. In those purposes, will be all done in the pre-execute thread, pre-execute method. The second one is do in background method. See, this is, as the name suggests, it is going to perform the background computations that can take even longer period of time. The computations and the results will be normally sent to the last method, which is shown in the diagram on post execute. This method contains the results which are obtained from doing background method. These results will be sent to the on post execute as parameter. Now on progress update. So what is this basically used for? Now on progress, as you can see, whenever we have to make an update or whenever we need to make a progress of the current state of the user interface, only in that purpose on progress update will be mainly used. So this is a method which will be used when I need to make any updations in the background processing or anything. Otherwise, on pre-execute, do in background, then on post-execute. This is how the cycle goes, life cycle goes. Only on progress comes into picture only when there is going to be some updation needed. Now, how to use the asynchronous task? See, we have to subclass it when it is to be used. Asynchronous starts via execute method. Execute calls do background method. It is an intelligent thread and which will be helping us to use its intelligent methods in order to run the thread. Now, mostly it is used in simple network operations where I don't need to download a lot of data. Disk bound task will be also making use of asynchronous task where very less than few milliseconds time is only needed. So in those purposes, normally I use the asynchronous task, I'm sorry. Having seen about the asynchronous task, which helps in background processing activities, now we are going to see uh, certain Android, I mean, background processing ways. There are 4 different ways. Android platform is going to help me support the background processing. First one, we have already seen the asynchronous task. Just now we saw that. The next one is going to be threads. Threads are nothing but they are classes which are helped to perform asynchronous processing. There is a package called Java Util Concurrent package, which helps in doing any processing in the background. We have some helper classes like executor, thread pool classes in order to help us to do that. Now, handler. Handler is nothing but, as I already told you, it can update the user interface. It provides method to receive instances of the message or runnable classes. Asynchronous task, we know, is one of the beautiful method or a special class which is used for background processing. The last one is service. It allows an application to implement longer running background operations. If we want to do the longer running background operations, then using this application, we can do that. This application basically helps us to start a service and stop the service explicitly. Okay, now having seen that, let me see. We are going to see in detail about the service class. Now, the service is nothing but it's going to be of 2 forms. Okay, before going to the 2 forms, let me tell you, it is only helpful for helping us to do long running operations in the background. It will not be helping us to provide a user interface. It's only for doing the background processing. Now, there are 2 forms. First form is called started, another is called bound. Started is nothing but it's going to be when a service is unbounded. It is whenever you want to start a service which is not bounded, I have to use a method called start service. Once the service is running in the background, even if the activity that has started the service is destroyed, even then the service keeps on running in the background. For example, we want to download or upload any file in the network. The operation keeps on doing. Only when the operation is finished, the service will be stopping by itself. We need not go and stop the operation on it. So that is the started. Bound. Bound is the second form of service. When we say a service is bound, then the application binds itself by calling bind service method. I have to use this to start it. A bound service will be offering client server interface to interact with the service, like sending requests, get results, or do any processing within the different processes. We have to use inter-process communication to do any activities within or across the processes, which is called IPC. It is nothing but inter-process communication. The next one is, as any other activity, service also has got a life cycle. In this life cycle, you can see 2 life cycles. See, one is going to be for unbounded service, another is for the bounded service. There are certain methods: on create, on start command, on bind, on unbind, rebind, and so many, on destroy, all these methods. Now, what we are going to see here is like every service, the entire lifetime of every service will be starting at on create method, and it will be finished when on destroy method is called. On create is initial setup, and when we release all the resources, we need to call on destroy method. Every service will be in between on create and on destroy. The only thing is, when it is a unbounded service, we'll be using start service. The service is started by start service method. And if it is a binded service, I have to create the service by using bind service method. The active life cycle normally begins and ends at the same time as that of the entire lifetime for all the services. If the service is bounded, then the active life cycle or the lifetime ends when I'm going to call the method on unbind. When this is being called, then we are going to finish the active life cycle of a binded method. Now, when you see the diagram, You can just see the diagram, and we'll see when a service is created. Normally, when a service is created using, say, uh, there is a method called, context.startService method. When I'm using that, the yes, the context dot start service method, I will be creating a normal service which is an unbounded one. When you see the diagram, if it is an unbounded one, always there will be on create method before on start command. If the service is a bounded one, then I have to use context dot bind service method, and on create method will be just before on bind method, as you can see in the diagrams. Now, having seen that, how do we create a service? See, when you want to use the service, then I have to have a service tag in the Android manifest. In the Android manifest file, I need to have the service tag. There is an XML code. I will show you the XML code right now. This is the XML block of code, which code will be having service name as well as the service has to be enabled one. See, when you can see here, the service name is given location tracking service, and the enabled is true. It's a Boolean value, either true or false. If it is true, that means the service is enabled. If I want to add some additional content, then intent filter will be added. Intent filter is used for controlling and sending specific commands to the service. Now, each filter will be having its own capability. If it is an explicit intent filter, then it always delivered to the target. If it is an explicit intent, it always is delivered to the target without consulting to the filter. It need not get any permission from the filter. It need not be filtered. But directly it is going to the target. But if it is an implicit intent, it has to be delivered to the component, then it has to pass through one of the components filter with the following action which is given here, it.uni.pr.dsj, all this is going to be the action, which is for the implicit intent. Now, when I have to start a service, I have to remember that I have to create an intent. Intent can be an implicit intent or an explicit intent. When it is an implicit intent, in that case, the service will be using one of the defined action to start the service. As you can see in this next class, okay, in how do we call or start a service? See, the implicit intent. I use one of the defined action as it.unipr tracker. This is given in the action code, which is used if it is an implicit intent. When it is an explicit intent, we'll directly use context and the service class name. You can see in this explicit intent in the code, you can see if it is an explicit intent, only the context name and the service class name alone will be enough. That is directly being used. I need not specify any action as it is given in the implicit intent. We have to remember one more thing. When I have to stop the service, either it is an implicit using implicit intent or explicit intent, I am going to use stop service method, which works for both implicit as well as the explicit intent. Now, once the service is running, the user has to be notified if there is any event occurring. That can take place using two types of notification. One is a toast notification, another is called the status bar notification. See, a toast notification is nothing but it's going to be a message that appears on the surface of the current window for a moment and then disappears. But the status bar notification is an icon in the status bar with a message, which the user can select in order to take an action, such as if you want to delete it, or you want to you want to see the message, or you want to reply the message, what type of activity you're going to start. So that has to be specified clearly. Now, when you're creating any bound service, what are the steps you have to take? First of all, when a bound service has to be created, I have to use the method bind service in order to create a long-standing connection. To create a bound service, we must implement the onBind method and return an I binder that defines the interface for communication with the service. Now, there are three ways how I can define the I binder interface. First one is the extending the binder class as it is given. See, if you want a service to be private to your own application and runs in the same process as that of the client, that is a common one, you can create your interface by extending the binder class and returning the instance by using the onBind method. If you're using a messenger, if you need an interface to work across different processes, it's not going to be common here. You can create an interface for the service with the messenger. Then third one is using AIDL. AIDL is nothing but Android Interface Definition Language. See, if you want your service to handle multiple requests simultaneously, then AIDL will be directly used. We have to make sure that your service is going to be capable of multi-threading. And I have to create a .aidl file that defines a programming interface. If you see the previous method, like using a messenger, that was also actually based on AIDL and its underlying structure and all. So this is what we saw today, binding and unbinding the method. Thank you, students.